second question we need to answer before doing the sizing is what is the mass flow rate of the cold fluid, so in our case of the water that will run through the pipe. So first we set which outlet temperature we want to reach, and this is set usually by what use we will do from this cold water. So here we need to have 50 degrees for the outlet cold temperature. Then we do the approximation that we always do in heat exchanger, that the heat exchanger is adiabatic, so that means that the heat that is given by the hot fluid is completely received by the cold fluid, and we have no heat losses to the environment. And then the question is what mass flow rate of cold water do we need? So in that case we do heat balance, but this time on the cold side, and we can write as before the heat flux. So the absolute value of the heat flux is equal to the mass flow rate of the cold fluid times the Cp of the cold fluid times the difference of temperature across the heat exchanger for the cold fluid. And because we have an absolute value, we also write an absolute value for the difference of temperature, and so that would be Tc out minus Tc in. So we know everything except the mass flow rate that we are looking for, so we rewrite the whole equation just to separate on the left hand side the mass flow rate of cold water, and then we can just calculate the results. And so the heat flux was calculated before, it's 1597 watts. The Cp of cold water is also given at the end of the exercise sheet, so that's the definition of the calorie. The Cp of water is very well known Cp, and then the difference of temperature is 40 degrees. And once you do the calculation, then you can calculate a mass flow rate of 9.74 gram per second, so like this. Or if you want to keep the same unit, then the mass flow rate of flue gas, then you can convert it and get 34.3 kilogram per hour, and that's the same just in another unit.